上网课我可以喜欢的，对。OK。Okay, I think there are very few people coming, so we recap what we do first. Then when people come, they will discuss the test. Okay. Please check out the lectures lecture notes. Okay, please check out the lectures lecture notes. I filled in a lot of things from the black box notes. Okay, please check out the lectures lecture notes. So recall what we have did last time about quotient groups, or the most important thing that you should learn from last lecture is the first isomorphism theorem. Okay, so what does first isomorphism theorem do? Okay, so so let's take a typical example, Z to Z. Okay, so Z to Z, how does Z looks like? So Z has infinitely many elements. Okay, so how do we, what kind of map we want to consider here? So let's consider a map called mod 3, for example. Okay, what does mod 3 do? Okay, mod 3 sends any element in X to mod 3. Okay, what is X mod 3? So X mod 3 gives you the remainder after dividing by 3. For example, what? For example, 1 gets sent to 1 mod 3, okay, which is 1. And 2 gets sent to 2 mod 3, which is 2. Okay, and then 3 gets sent to 3 mod 3, which is 0. Correct. Okay, if you divide by 3, what's the remainder you left? Okay, so you should be able to see that if I put any number here, there's really only 3 numbers will popping out. Okay, either you are divisible by 0, either you are 1 left after you divide by 0, or 2 left. Okay, these are the 3 possibilities. So meaning this map is not, it's not 1-to-1, and also not, is also not on 2, right? Because I only reach 1, 0, 1, 2 only. 3 number I can reach. Okay, I won't reach other number like -1, 4, 5, so on. Right? So this is neither, or this is neither, neither 1-to-1 or on-to. Okay, but we can always make a non-onto map onto. How? I can just consider the image of the map mod 3. Okay, I can just consider the image of the map mod 3. Okay, so let's call this image Z3. Okay, there's only 3 number inside here. Okay, so here is Z3, 1, 0, 1, 2. Okay, inside the infinite set. Okay or not? so that it surject onto the image. Okay, it doesn't surject to the codomain, but surject to the image. Does it make sense? Okay. Okay. But you said this is not injective, right? Okay, that means the kernel is not the trivial, okay, trivial subgroup. Yeah. Oh, first of all, you should check that this mod tree is a homomorphism. Okay. So meaning if 3 plus 2 mod 3, so is this a homomorphism? Homomorphism or not? So let me check. Is this a homomorphism? That meaning, for example, 2 plus 3 mod 3. Is it equal to 2 mod 3 plus 3 mod 3? True or not? Is this true? Okay, if this is true, is this true for general? X plus y mod 3 equals to x mod 3 plus y mod 3? True. Okay, because this is what you prove in discrete maths or number theory. Okay, if not, you can try and prove it. Okay, x plus y mod 3 is equal to x mod 3 plus y mod 3. Okay, so this is a homomorphism, not injective, meaning there's a kernel. So what's the kernel of this map? What are the things that get sent to 0 here? Huh? All the multiple of 3s. Okay, so we can see that the kernel of mod 3 is the multiple of 3. Okay, multiple of 3. I think you should ask a question. What's the group structure on this Z tree? What's the group structure here? How do I compose 0, 1, 2, 3, 0, 1, 2 so that I stay inside 0, 1, 2? How do I compose? How do I compose them? Do I just add them? 2 plus 2 is 4. 4 is not inside here. So how to stay inside that tree? There are only 3 elements here. I need to consider addition up to mod 3. Okay, addition up to mod 3. So let me put the group structure up so that everyone knows what's going on. So the group structure here is plus mod 3. Okay, plus in the mod 3 sense. Okay. Okay, so this is the kernel. So is this kernel normal or not? Kernel is always a normal subgroup. Okay, so kernel is always a normal subgroup. So normal subgroup has one nice property. What's the nice property? If I have a subgroup, right, what can I do to my original group? Huh? If I have a subgroup, what can I do? I can partition my group. Okay, I can partition my group. So I can partition my 3Z using coset of 3Z. Okay. So how many coset does a 3Z have in a Z? This one I think you cannot use the Lagrange theorem because everything is, I mean, at least 2 things is infinite. So how many? We got 3Z plus 1 and 3Z plus 2. Okay, plus 3, then you go back to the same equivalence class. And this is normal, right? What can I do? I can take Z quotient by 3Z. What are these? These are the set of coset of 3Z. Okay, so in this case here, we have 3Z, 3Z plus 1, and 3Z plus 2. Okay, so what have we established last time? So if we have a surjective map, okay, mod 3 to Z3, okay, we called it Z3 just now, and we have Z mod 3Z here, okay? there's a commutative diagram here. Right? There's a commutative diagram here. So what's the commutative diagram here? Okay. From Z to Z mod 3Z is what? Is a quotient map. Okay, what does this do? This just sends any element to the coset X. Okay. And then what's astonishing is we have this isomorphism here. Okay, phi bar. Okay, and then this quotient map here is what last time Jingpo asked about the canonical map. Okay, so this is the canonical pi map. So you sense every element to its coset. This is the canonical pi map. Canonical means what? Means what? Is the most direct one, is the obvious one you have to define. Okay. And then there's a isomorphism back to the image. Okay. So this will give you the isomorphism between Z mod 3Z and Z3. Okay. Remember what Z mod 3Z is coset, but Z3, what do you have? You have 0, 1, and 2. Okay, so these are really different sets. They are different. Okay, these two sets are different. Okay, so I cannot put equal here. They are different elements. So I put isomorphisms here, meaning they compose the same way. Okay, so you should ask how they compose. Okay, how they compose. On the right hand side, how they compose. They compose by plus mod 3. Okay, on the left hand side, how they compose. Coset, how to compose coset. We just multiply coset together. Okay, we just multiply coset together. Recall that how we multiply coset together. For example, AN times BN. What do we get? Okay, what is AN times BN become? We get ABN. This is not always true. This is true when N is normal. Okay, normal, typical subgroup don't give you this composition. Okay, only when N is normal, then you can do this. Why? Because when N is normal, NB equals to BN. This is what is tested in your exam. Later we'll discuss. Okay, when N is normal, we have NB equals to BN. Okay, you can swap with the element. The subgroup can swap with the element. Okay, so become A, B, and N. But N is a subgroup. So N times N is still a subgroup. Okay. So A, N, B, N becomes A, B, N, N. And then A, B, N, N becomes A, B. Okay. So only when N is normal, you can do this. Okay. So this isomorphism theorems always applies when N is normal. Okay, so meaning every normal subgroup is a kernel of this canonical map. Okay, every normal subgroup is a kernel of a canonical map. Okay, so we have established every kernel is normal and every normal is a kernel. Kernel of which map? Kernel of the canonical map. Okay, canonical map. And then you need this for your assignment, right? Okay, I ask you to look for a few matrix groups. And then another thing is we will say that the morphism of 3 factors through the canonical map pi. Okay, we'll say that this morphism mod 3 here factors through pi. Okay, because this diagram here commute. If I go horizontally, it's the same as I go in this triangle. Okay. Okay. Yeah. So in this sense, we'll say that the morphism mod 3 factors through pi. Okay, factors through pi. Okay, because I can write mod 3 equals to pi composed with b. Okay, so it factors into two morphism here. Okay now. Okay. So there's the commutative diagram here. Any question or not? Okay, now I don't want to ask you to ask question. I want you to have your own idea. Okay, why people don't have question? Because usually they don't have their own idea. Right? They don't have their thinking. Okay, you need to put your thinking in. Maybe you are trained. What do I mean by trained? So when you do wrong, right? When you are small, your parents hit you, your teacher hit you, right? Got or not? Got or not? If you do wrong, people hit you or punish you. Huh? Of course, right? Then you are very scared to make mistake now. You never, very good. Okay, good. Okay. So you like people torture you. Okay, that's your hobby. Okay, but what I want to tell you is don't afraid to make mistake. Okay，不要害怕有自己的意见。OK，错跟紧改过就好。OK，改过就好，错跟紧，但是你要改过。OK，要有自己的意见。OK，you need to put in your own independent thinking. OK，right？So please have your own thinking. Okay, I don't want to ask you to ask question already. Put your own thinking. Once you put your own thinking, you will start asking questions. Okay, once you put your own thinking, you will start asking questions. Hey, why are you facing there? I'm not there. Screen also not there. Okay, so yeah, put in your own thinking. If you are wrong, it's okay. Change it. Okay, don't be stubborn. Okay, your class are quite stubborn sometimes. Because of whatever I say, you just argue with me. Please try and listen. Okay, just listen. Okay, I'm not trying to like hide me, right? Trying to destroy you. No, right? We will come here to grow together. Yeah. Oh, yeah. You got question? Yeah. Right? You try. You try. I like important question. You try. Quick. Don't have much time. Quick. Yes. 很重要. Yes. Alright. This is for your uni, not the other uni. Okay. This is only for your uni. I also not happy about the system. Yeah. I don't know. I'm not the principal. Every year you need to maintain. Once you drop. You pay your own. Not me, not my choice. I also not happy about this. So if you want to give people merit, right? You give on people merit, then why you keep pushing people around? Yeah. No choice, because you choose here, you choose the system. Either you live with it, either you leave the system. That's all. Then, if you are the principal, you can change. Can change. If you are the principal, you can change it. Okay. Recording. After class, I tell you. Okay. Okay. Okay, are you done with your important question already? Done. Okay, you can come to my office later. Um, all right, about this quotient group, any problems with this quotient group? Any problem? Question about this quotient group? I think this quotient group is really the essence of the group theory. It's a, it's the essence of the group theory. Essence 精华 you know chicken essence 那个 brand 基金 essence of group theory okay maybe we get back the exam paper first 雪梅严家 Dishon 伟泽 not here 蛋呢 you're not here 乐天林生德瑞 yeah 真诚哦上了 OK 了真诚 Steven is Steven here not here Ryan 林晶 where's 林晶宜州 OK 金波思雨一维 Michelle 嘉文 here 呢嘉文明修解言孙玲 Ellie not here is Ellie coming 可以天孙玲啊林英 Syed 燕博嘉业柳晴一定多宁英奇华英我是说多宁 Grace Venus not here 陈烨丁宇德轩海伦董洁子源李凯子轩鼓励 is 鼓励 here OK 边科Okay, please take a picture as usual. Take a picture of your test paper. Don't write anything on it because you need to return to me later. So take a picture of it. We will discuss the question and any marks dispute come to me after this hour when you return the paper. Please don't write on it. Last time there's a class, they try to cheat me. Is Jiawen or Ellie reaching or not? Jiawen the way? Yes. 没有。Okay, I think we just discussed. So in general, I want to see this result in two ways. Okay, please see this result in two ways. So meaning I want you to assess yourself individually and also this class in group. Okay, Jiawen, yeah. Jiawen. Yeah, I want you to compare yourself between now and last semester, the midterm I gave you. Because this midterms, strictly speaking, is not too less hard than what I gave you last time. Okay, so I'm actually very happy about your result. Okay, because your average is about 49 this time. Last time is 45. This means you guys improve. Okay, improve. So you need to see whether individually you improve or not. Okay, please compare to last time. Okay, what have you done? What have you did? But for those who just came here, what do you feel about this exam, Jingsen? Jingsen? How do you feel when you read the question? Oh, only the last question is more difficult. I see. Okay, the other question then easy. Not easy. You can do it. Okay, good, very good. 乐天, how about 乐天? What do you feel? Not feeling good? Okay, sure. What's the difference? Any difference or not? When you do this question? 乐天. Any differences when you do this question? Ellie, anything you feel different? Hey, excuse me, listen. Don't do enough revision. Okay. Okay. So you think that if you do enough revision, maybe you can do more. Okay. Okay. Why is it? Why is it very easy or easier than last time? It's because you done well, eh? Ah. Okay. Have the experience. So what I want to say is your mind is starting to change. You are more sensitive to statement already. You know why I can see this? Because when I see you answering question one, you have your own idea start to germinate already. You don't just get 0 mark from that section. Okay, you get partial mark. True, false, and then try to attempt prove a little bit or give counter example. Okay, so this is the change I want to see. Okay, not good result. Okay, not just good result. This is the change I want to see. This is the change that keep you going in your life. Okay, you just keep moving on every day, small change, and then slowly you will pass by the strongest guy in this place. Okay, just small change every day, a little bit change, small change is enough. Okay, maybe you are slow, it's okay, but there are so many days ahead. Okay, so please change. Okay, I'm happy to see this change actually. Okay, I got a result that I can tell my boss already. Okay, good, very good. So that very good. Okay, so please change. Please change. I see the change in you already. Please slowly change it. Okay, maybe we'll discuss question first, then later we will talk more about statistics, the test statistics. Okay. So first question, usually I will put true and false. So here is a true and false question. Concept question. For the first question, for all lambda in multiplicative real number, so meaning there's no zero inside this real number here because zero is not invertible. Then the subset H equals to this matrix, invertible matrix, but determinant A is equals to lambda. Form a subgroup of the invertible matrix, size 2 times 2. Okay, so a lot of you mistook this question here. You thought I asked you about GLN, lambda not equal to 0. But I picked lambda first for all lambda. So I already fixed a particular lambda. For example, lambda equals to 2. Then is the set where the determinant A equals to 2 is a subgroup or not? Form a subgroup or not? No, right? Because if determinant of A, B equals to determinants A times determinants B. So 2 times 2 will go to 4. It's no longer 2. So I think less than 5 of you see this because your discrete statement is not good. Okay. So you need to read how to read this statement here. For all lambda is upside. So you need to beat lambda first. Meaning you still not good in reading the statement. Okay. 2. Let A and B be subgroup of a group G, then A union B form a subgroup of G. Okay, a lot of you managed to see that this is an assignment question. But in the assignment asks you to prove that this is not true. Okay, now what do? I just ask you to show that it is not true, meaning you just give a counter example. So do you have a real example to tell you why is it not true or not? Okay, so this is the question asking. So very typical example people give. Group Z. Okay, subgroup 2Z and 3Z. Multiple of 2 and multiple of 3. So if you take the union, 2 and 3 is in there. But is 2 plus 3 there or not? 5. 5 is not a multiple of 2 or 3. So it's not there. It's not a subgroup, not close. 3. Matrix multiplication in M2 is commutative. I think most of you got it. Most of you got it. And actually, I'm quite happy one of you has the same answer with me. 4. Z plus is a symmetric group. Okay? A lot of you make a small mistake. You thought when one generates the group, there's no negative there. So when we say the group generated by one element means what? The inverse of the element is there. Okay, the identity is also there. Okay, all the negative, all the integer power of x should be in there. This is what it means by generate. Group generate by one. Okay, so I'll show you the step. You can have a look. And then if you want to ask question, you can ask. You can try and compare with your answer and then see how to improve yourself. Okay, so find the question on question 1 here. You're about your own answer or so you can take notes on how I give the marks. Later, if you see I give less mark or what count wrong, you can let me know. You can adjust. So if you just write true and false, I give you 2. Okay, and then if you can explain well, prove or give counter example, I'll give you 2 marks, extra 3. Okay, so find any question? Question 1? No? May proceed? May proceed? Okay. Mostly okay. Okay. Okay, let's go to the next question. Okay, question 2. Let H be a subset of a group G. Prove that H is a subgroup of G if and only if H is not empty and whenever AB in H, then AB inverse is in H. Okay, so this question here, do you feel familiar or not? This is the day when I go wow, right? Have you think of it? Why is it true? Also, especially for those who use it. Have you do it? Have you test it? Have you prove it at home? Why is it true? If you do that, then you come to exam, you will know how to do, right? Okay. So for the things that you don't know, okay, you should go and pursue it. Okay, in university, you should go and pursue the things that you don't know. Okay, it's not that I tell you what to do. This is important. That is important. Then you go and do. No, this is not true at all. This is wrong. Wrong education. Exactly wrong. Okay, in university education, you should go and pursue what you like, what you want to do. Okay, why you every day bailan? Because you do what you don't want to do. Go and choose what you want to do. Think carefully what you want to do and then do it. Who wants to do what they dislike? Correct or not? 对吗？有人喜欢做他不喜欢做的事情吗？没有，没有的。这么你摆烂，因为你不喜欢，不喜欢不要做咯。但是 if you choose to do it, then you need to do it properly. 你已经选择了，或者你被逼选择 ，you are forced to choose it. How? Then do it properly and then leave it good. That's all, right? If not, you are just wasting your time here. Seriously. 讲真的 if no one sponsor me for mathematics, I also won't go for mathematics. Why study mathematics? Right? You don't earn money, correct? You don't earn money. Maybe those who earn money is a TikTok guy. Are you the TikTok guy or not? If no one sponsor me, I also won't go and study. You know, I study maths for how much or not? You know, from bachelor to degree. I don't have single money coming out. They all sponsor me. You know how much in total? No. 8 years. No. Not dollar. Wait, dollar. Wait, that's my next time. No, not enough. $100,000. So ringgit Malaysia is 1,200,000. 1 million, I can buy the house outside the Xiamen University, you know, the corner house. 1 million. You know.
So your market value is so high.
So I'm not come here to play, you know. Don't play with me, okay? We're supposed to be serious here. Okay? We have problem, we solve together. Okay or not? Okay, we're not coming here to play. Okay. Yeah, okay, so prove this. So less than 5 of you read this question wrong. Okay, read this question wrong. So you read like if and only if H is empty and something else. So here, so this is the logic line here. P if and only if Q and R. So how do you read this? Okay, you don't read like this, okay? So the most important thing is the N and O first, okay? So there's a hierarchy. N and O and then until the implication. All right, this is still discrete math stuff. It's natural. You slowly pick up when you learn maths. I also slowly pick up when I learn maths. I never had discrete math before. Okay. So this is the right logic statement here. P if and only if bracket Q intersect with R and R. Okay, so how to prove this? So you prove 2 directions here. Left to right, right to left. Okay. So left to right, what do you do? Suppose H is a subgroup. You want to show that H is not empty. And A, B inverse is in H for all A and B. So how do you show that? Why is it A not why is it A not empty? Because H is a subgroup. Subgroup says what? There's one rule that subgroup says. identity element must be in there. Okay, so you must at least have identity. This is exactly the trivial subgroup that Shulin said before. Okay, trivial always the least you have is the trivial subgroup. So you must have identity in there. So it's not empty. Then take any AB in H. Since subgroup H is a subgroup, B inverse must be in there. And H is closed, so A times B inverse is also in there. Okay, so this direction is easy. So I put 5. The other direction is harder, trickier. Okay, so suppose that H is not empty whenever AB is in H, then AB inverse is in H. Okay, since H is non-empty, okay, we can find an element there, which is X. Okay, so what do we do? What do we need to do to show H is a subgroup? We need to show that there's an identity in the subgroup. Okay, inverses. Right, it is closed. 3 things. Okay, the first thing you can see is identity is in there. Why? Because you just take AB equals to X, the non-empty things. The non-empty things not necessarily is identity. Okay, maybe it's identity, maybe something else. But whenever you have this non-empty things, that sentence create the identity for you. Okay, it gives you the identity. X times X inverse is the identity. Okay, so the identity will be in H. Then we want to show that all inverse exists. So how to show? We just take AB inverse, right? We just let A equals to identity, and then B is A inverse. E times A inverse is A inverse. So A inverse is in H. Finally, so we want to show that for all A, B in H, A times B is in H. So how? How you write it in an inverse form? You write it as B inverse inverse. Okay. B inverse inverse. Okay. So A of something inverse is always in H. And so this is the trick here. I think the hardest one is this closure. But for those who can work out this question, you can work out this closure, which is good. Okay. Any question about? Please read this again and then see if you have any question. Yeah, think so. Circle something. Yeah, I circle something. So so you need to like write properly like this. But I don't penalize you. But tell me why you can do this. Because there is a non-empty element there. You just take that. You don't say that you have a, you don't make full use. So I don't penalize you if you don't say that it is not empty, then I can pick one element. If you just pick one, I just let you go. Yeah.
That's question.
Mm.
So because we assume it's not empty,
Sure.
I assume that it's in H.
Not empty, there's only one. I mean, maybe there's only one thing there. Not empty meaning one. Meaning what? There's at least one thing. So you cannot assume there are 2 things. Maybe there's only just one thing there. Okay, one guy. So if there's only one guy there, I can create another EE for you. So meaning if you have a non-identity element, there's always identity with that element. Okay? Any question about the solution here? Any question? No? Others? Happy? Not happy? Not happy, you have to work hard. Okay. Yeah. If you have problem, you just come and see me. All right. Like Yanker say, straight away come and see me easier. Just ask. Right. Okay. Just straight away come and ask me. Right. Because I cannot almost fit every body taste, you know. So sometimes you have a weird taste, then I need to accommodate to you. Right. So you have to come and see. That's why we have office hour. Yeah. Huh? When I'm free, huh? After this class or Friday, 1 to 3, I have office hour. You can come and see me. Yeah. You can come and see me later after class. After class. Yeah, after class. Okay, let's proceed. Question 3. Let G be a fixed element of a group G. Prove that conjugation by G is an automorphism of G. There's this map here, phi G, G to G, sending X to G, XG inverse is an automorphism of G. Okay, so what's an automorphism? I introduced to the top. So an isomorphism, phi G to G from a group to itself is called an automorphism. Okay, when it is an isomorphism and from G to itself, then we call it an automorphism. So what you have to show here? So most of you realize you have to show that this is actually an isomorphism. Okay, quite a lot of you did good job here. So you see that this is actually an isomorphism. So to show it is an isomorphism, what do you do? 3 things to show: group homomorphism, injective, and surjective. Okay. And then another trick to show injective surjective is to find the inverse. Okay, show that Fg inverse, Fg and Fg inverse is the identity map. Okay. Yeah, most of you did this well. Actually, this is coming from one of the lecture proof, right? Yeah, lecture proof. Okay, so this is the answer here. So you have Venus, you can come and get your exam. Okay, so first I show that it's an homomorphism. Oh, I think I need to put a G vector. Put a G on. Okay. Okay, and then I showed it is bijective because I can find the inverse. Okay. I think if you mention that you want to show adjective, I think I will give you 4 marks. Just check if you got the marks. If not, you can claim. If you just mention you want to prove bijective, I will give you 4 marks. And then to show them, I give you another 4 marks. Okay. If you mention you want to show bijective or injective, or you want to show invertible, meaning you need to show two identity here that you need to show, then I also give you 4 marks. Okay. You know what you want to do, I will give you mark. And then you do it, I give you full mark. Okay or not? And if you know what you want to do, I give you marks. If you do it with what you want to do it correctly, I give you full marks. This is same as your life. You only get married if you know what to do. Okay. So the way I set this question is really the same how you will face your life later. Okay, any question about this part here? I think this is quite straightforward for what to check. But if you don't understand the map, then you really GG. If you don't understand the map. Okay. Yeah. Okay. So to show, to check is okay, too easy, but to understand is hard. It is always hard to understand. Okay. Okay, next question 4. So this is a thing that come up from a lecture, not textbook. Ziqian said after the test, he tell me, and there's a lot of questions coming from textbook one. Is it? So that's mean you read the textbook. Yeah. So for any elements AB in a group G, a commutator of AB is the element ABA inverse B inverse. Okay. And then I set the question here to see what's the role of this commutator. Okay, prove the following are equivalent. Okay, for elements AB in G, two elements AB commute. That is AB equals to BA. Second, ABA inverse is equal to B. Why is this significant? Because the conjugate of B might be something else. But in this case here, conjugate of B is B. Go back to Excel. Okay. And then third, the commutator is just the identity. Okay. If we check that the commutator is the identity, then we will see that AB and BA commute. Okay, so how to prove this? There's nothing much to do actually for this question. You just multiply with the right element, then you will get what you want. So the thing I want to test you in this question is actually the logic. TFAE, the following are equivalent. Okay, I caught some of you. You don't understand why is the following are equivalent. You just try to prove every segment. How to prove it? There's nothing in condition for you. I didn't tell you what's AB. So when we put the following are equivalence, meaning each segment implies every segment. Okay, so this is what it means by the followings are equivalence. Okay, so you can see that there are really how many segments inside here? How many segments? How many segments inside here? 6. Good. 6. Okay, every line if and only in 2 directions. So do you have to prove 6 directions or not? No, quite a few of you prove 6 directions. But you just need to produce a path here so that you can go to every path that you want. Okay, you just create path. For example, I create a path, go from 1 to 2, 2 to 3, 3 to 1. Okay, so you should ask how I go from 2 to 1 in this case. If I have this blue arrow here, how I go from 2 to 1? How do I go from 2 to 1? 2 to 3, 3 to 1. Okay. Yeah, so this is the discrete math stuff. So as long as you can produce a what do you call Euler path. Euler path, you pass through vertex every time, every one once. Okay, you produce the Euler path. Okay. Yeah, this question is either you get it, either you don't get it. What to do? Okay. Any question on this part? Yeah. Okay. Okay. Okay, question 5. Do you guys feel familiar about this setting? Question 5. Do you feel familiar about this question format here? Identity is the assignment one question, right? Actually, you really use the almost same strategy to prove. Okay, let's see what's the question here. Let E denote an identity element in set X with an associative law of composition. A left inverse of X is an element L such that L composed with X is E. A right inverse of X is an element R such that X composed R is E. Okay, so one is composed left, you get identity. One is composed right, you get identity. Then prove that a left inverse and a right inverse of an element X is a set X with an associative law of composition. Must agree. Okay, they must agree. So if left and right exist, they must agree. So if left identity exists, right identity exists, they also must agree. Okay, so how to do? You just start with the left inverse. Okay, you start with left inverse. And then you create out of nothing, or the identity, you create the right inverse. And then you use associativity, okay, to get rid of the left inverse. Okay, and then you left with right inverse. So then left inverse equals to right inverse. Okay, any question about this step? Yeah, and then I see quite a lot of you also using your own step when you show the left right identity to see. It's fine, but I prefer this way. Because why do I prefer this way? I can immediately see that lambda equals to r. That lambda equals to r. They must agree, right? So I'm going to show L is r. Okay, so I prefer this writing style. Straightforward. People can check and see. Okay, yeah. So when next time, whenever you show some things want to agree, you can start from one thing first and then end with the other thing. This is always workable. Yeah, because you want to show two things. Okay. Any question? Okay, next. Okay, question 6 is a calculation type of question. I don't ask you to prove, no need to prove. You just calculate. If you are correct, then you will have marks. If you show some step, I can give you marks if your answer is wrong. But if you don't show step, I cannot give you marks. Okay. So one, express the product as a product of disjoint cycle. So for this question, if you don't know what the disjoint cycle is, then you don't know what to do. Okay. What you do is you just expand it out. Okay, you just expand it. And then write it as disjoint cycle. Disjoint cycles means what? The cycles don't have any same number. Okay, for example, is this product disjoint or not? No, right? For example, first and two, they have in similar three inside there, so they are not disjoint. How about two and three? Are they disjoint or not? No, they also have three. Okay, all of them have three, so they are not disjoint to each other. So you need to try and compose them. Okay, see what's the disjoint cycle you can get. What is the maximum order of an element in Z6 times Z15? Okay, so what's the element here? So you can see that in the first spot here, everything will go to identity when you hit 6 or multiple of 6. And on the right, you have 15. So everything will go to 0 when you have a multiple of 15. Okay, multiple of 15. So the maximum order is what? Is the LCM. Okay, when they go to 0 first time together. Okay, LCM will give you the number when they first time go to 0 together in the product group. So in this question, you are asking for the maximum. So you're asking for the maximum n for any AB such that this is equal to 0. Okay, maximum for the n. So where is the maximum least number for AB to go to 0? Okay, maximum least number. Actually, this idea you see in analysis of maximum least. Have you guys learned inf? Got inf or not? No, don't learn. Learn inf, lim soup, don't have. Oh,
So,
yeah. Yeah. Lim soup is consider what's the minimum of soup and the maximum of it. Okay, so part 3. If the permutation 1, 2, 3, 4, 5 in A5. Okay, so most of you know what to do. You just split into product of transposition. For those who don't know how to do, I feel a bit wasted a bit conceit. Okay, so you should know how to do this. This is the easiest point you should get. Okay. Yeah, so this is the answer here. So if you don't provide step, if your answer is wrong, then I cannot give you mark. Okay, if you provide step, your answer wrong, I can give you partial marks. Okay. If I don't give you mark, you can come and see me. Okay, any question on this calculation question here? Question 6. Calculation part. Okay. Hey, hello. Behind there become kopitiam already. Kopitiam. Okay. Okay, so 7, right? 7 question here is the trick question I gave in this test. Okay, so if you can pass this question, you are distinction. Okay, high distinction. So if you can achieve something in this question, then you are suitable to do pure maths. But if you don't do good in this question, you still can do pure maths. Okay, there's no logical contradiction here. Okay. Everyone can do pure maths. Okay. Yeah, correct. Everyone can do. Okay. So first question here. Let H be a subgroup of group G. The number of right coset is the same as the number of left coset with respect to H. Okay, I should ask you to show left coset and right coset of H is the same. This two number is always the same. Okay, and then I give you hint. So in the exam, right, if I give you hint, right, that's mean I don't want you to think more about how to solve this question. Just try and think how this hint can solve it. Right, that's the reason I give you the hint. Okay, don't start from scratch. Of course, you can start from scratch if you want, but that's the purpose of the hint. And then part B, let H be an index 2 subgroup of a group G. Prove that H is a normal subgroup. Okay, actually at start there's only B, and then I think that maybe it's to feel out the logic. Maybe we should show A first. Yeah, although I thought a bit about index 2, but 2 I also want to test you about well-definers and bijective. Can you do that or not? Okay, most of you cannot do well-definers because maybe I don't stress it enough. But let me tell you, don't just focus on what I stress. Okay, everything what I say is important. You know, everything I say is important. Okay, there's nothing I say is trivial. Okay, everything I say is important. Don't wait until I say, this is important, this is important, this is important. Yeah, please don't wait until that stage. Everything I say is important. Everything I say there's something wrong, you should ask. Or something feel weird, just ask. Okay, maybe I make mistake, then we change it. Okay, open to change. Okay, yeah, okay, so let's go to the first part first. So first part, there are 3 parts here. I will give marks, 2 marks, if you just tell me the flaw for each question. So if you tell me I want to show that phi is well defined, 2 marks. I want to show that phi is injective, 2 marks. I want to show that phi is surjective, 2 marks. And then if I show all this, I see that if phi is bijective, I'll know that the 2 sides of the set has the same cardinality. Okay, if you just tell me the outline, you will get 8 marks. Okay, if you tell me the outline, you will get 8 marks. And then a lot of you understand the map wrong. You need to know what's the set you are considering. What's the element in there? Okay, the element in there are coset G times a subgroup. It's not GH1, GH2. No. Okay, this element are coset G1H or G2H. Okay, this is the map I define here. So for every, what's changing here? So you need to know what's the things is changing. The thing changing is G, not H. H is already fixed here. Already fixed in the question. Already fixed the H. What is changing is G. So what you need to consider is G1H, G2H. Okay, not GH1, GH2. Little H1H. Okay, you thought it's an element. Okay, no. The element now is already a set, coset. Okay, so first to show well-defined, what do you show? You have to show that if x equals to y, then phi x equals to phi1. Okay, this is well-defined. How is this differ from injective? Injective is what? Injective is exactly the converse of this segment here. If Px equals to Py, then x equals to 1. Okay, so this is injective. So these two are converse to each other. Okay, so the first direction is well-defined, second direction is injective. Okay, surjective, I think most of you somehow see it, but you cannot write it properly. You cannot find the pre-image for it. Although you have a hunch that, oh, this surely surject because I can find, but you don't tell me how to find. Okay, so I cannot give you full marks. I give you partial marks. You need to tell me how to find it. Okay. So let's start from surjective. Maybe surjective easier. So if I give you hx, so who should map to hx? Okay. In fact, x inverse h should map to hx because under this map, x inverse h becomes h of x inverse inverse, which is x. Okay, so this is how you show surjectivity. Give you an image, tell me the pre-image. Okay, so this is the surjective part. Injective, well-defined, you need to use the TFAE in the class. Okay, tells you when the two concepts are the same. When AH equals to BH, it is when A inverse B is in H. Okay, that's what you need to use. A bit tedious, I would say. That's why I allocate so many marks here, because it's tedious work. Okay. You don't want to show in this way also can. You can show me the invertible, find me the inverse, and then do the inverse thing. Okay, you also can do that. P inverse P is identity, P inverse is identity. You also can do that. Okay, but if you do it this way, it's kind of long. So that's why I put quite a lot of portion here, 20 marks. And then I also thought that this is just a bijective map, so I think you should score it, but most of you didn't. Okay, so the second part here. Let H be an index 2 subgroup of G. Prove that H is normal subgroup. Okay, so what's the conceptual understanding here? For this question, if you like somehow guess what you want to do, I'll also give you partial marks. Okay, if you can link this question subgroup to index, for example, there's a theorem in the class you learned that if every left coset equals to right coset, then the group is normal. If you just write that line down, I'll also give you marks because you somehow have the right direction to go already. Okay, just that you didn't write it fully. Okay, so what does it to do with this? So let's say H is index 2, meaning what? You can cut the group using H and AH into half. Okay, and then you can cut it using the right coset as well. Okay, because last time I say that in class index means what? Number of left and right coset. But at the part A, what do we show? We show that number of left coset and right coset always equal. Okay, that's why we can do that definition. But you see, left coset, right coset partition the set. Okay, everything not in H is in AH. Everything not in H is in HB. So this means what? AH and HB will be the same. Okay, so there's only one coset here. I mean, two coset, but a non-subgroup coset. So this means what? Every left coset is equal to the right coset because H is equal to H, AH is equal to HB. Every left coset is a right coset. No, so H is. Okay, so this step is short, but I give credit to your idea. Okay, I give credit to your idea. So as long as you have idea working, then I will give you marks. So there are only actually 3 lines of this question here. So if you can say that a subgroup is normal if and only if every sub coset n is a right coset, I'll give you 5 marks. Okay, and then you notice that there's only 2 index, okay, 2 coset. And then you try to equate the 2 coset, I also give you 5 marks. And if you can see that the two coset actually equal, and then try and deduce that every left coset is the right coset and H is normal, then I'll give you full marks. Okay, so why I thought say that if you do good in this question, you can do pure maths, because pure maths really need idea connectings. And so if you have little idea, then in the right direction, I'll give you marks. Okay. And actually, this question is kind of a deciding question, deciding marks for you guys. Okay, because some of you did good in this part, and then you get quite a lot of marks. And then the other, if you don't do, you do good at the front, because front only has little portion, then you don't get as high. Okay. So let's any question about this question before we jump to statistic? Yes. Okay, so there's some dangerous people you need to be careful. I want to warn some of you. So for example, San Yanke and Zeri, please be careful. Please work harder. Okay, otherwise it's very hard to save you guys. And please work harder. If you have any problem, Zeri, Yanke, and San, please just come and talk to me. Okay, yeah, you have to work harder, otherwise it's very hard. And Yuanjia actually why why you 翻车? You don't sleep well, is it? You come late on that day? Yeah. 因为 I thought your assignment is quite good. Ah, okay. Okay. Yeah. Yeah. Please be aware. Also 雪梅. But I see you improving, so keep improving. Okay, keep improving. We will scale the score until the average is 70. Okay, and then I'll let you know how we scaled it. Okay, we have 4 high scorer this time. Okay, we have 96, 91 from Suoning and Ziqian. Okay, 96 above 90. And then we have 2 about 80, 80 and 81. So Abang Adek, Jingbo and Waying. Abang Adek, okay. Yeah, Jingbo and Waying. So you can see that this batch is different from what we get from last time, right? So the last will be at the first will be at the last. Okay, 在前的要在后，在后的在前。As long as you hardworking, you can keep moving forward. Okay, just keep moving forward. Okay, don't wait, don't compare. Okay, you compare to yourself. Okay, just keep moving forward. Okay or not? 外音讲啊，痛改前非也不是痛改前非。Because my last time did well, right? They did only 40. It's a very sad. And this time he got 80, right? Yeah. So you just how many effort you put in? You said last time. Hey, you told me. You told me how you prepare for this exam. Every lecturer he reached 3 hours. You see, how much people put in the effort. How much effort people put. Okay. Yeah. So Ning and who else? Ziqian. How you guys prepare? You don't know. Do the logic, right? Okay. You do revision or not? Yeah. You do question or what? Look through of them. Okay, at least you read through, right? Yeah. They get the logic right. Yeah, true. The channel, read the whole textbook. Okay, also good. And then Jimbo every week come and do the tutorial question. Yeah. Okay. Yeah, in general, I'm happy about this result. I have something to post at least now. Okay. Yeah. So I mean, I really, really, how to say, really, I really care about your development. I really care about your development. So your individual development, you have to check, okay, whether you have advanced from last time or not. If you don't, if you resist some more negative, then you need to check. Okay, you need to check what happened. Okay. Maybe your focus is not here, maybe your focus is in the other place. So try and adjust it. Okay, because this is your life. I cannot say, hey, you keep improving, you must keep improving. No, not like that. You just make sure you go on the right track. Okay. You know that you are not doing good, and then what you're gonna do. Okay. Okay. But if you are a person that you want to keep improve, please keep improving. Okay? Yeah, I'm the person. Okay, I'm that person. That's why I have feel like actually I'm shocked actually when I first come to this uni. Like everybody is like not studying. They just want to find girlfriend, boyfriend. I mean, sure, that's fine, that's fine, that's your life, okay? But it's not my life, at least when I was studying. But if you want to do that, make sure you have time, okay? Proper time to study as well. Then it's okay. You are free to do whatever you want. But if you don't do good, and then it makes you feel guilty for what? Right. Fair enough. You can do whatever you want, but you have to be responsible. Well, you have to be responsible to your own. Yeah. Okay. Any question before we leave this test? I'm happy. I think I won't see you guys anymore if you don't do pure math, so I won't see your class anymore after this class. So yeah. So at least I have something to take away. Okay, before we leave. Okay. I probably won't see you if you don't do pure math anymore. Okay. Oh, okay, yeah. And yeah. Yeah, actually I'm quite happy. Because all this time I feel very kind of sad and disappointed sometimes. But at least you guys are doing it, so should be okay. Should be okay. You just keep working hard to get what you want. Huh? Because every time when I mark assignment, I still see the same mistakes. I still see the same behavior. Let me like what you know, I'm an abstract person, I'm an abstract person. I'm practical, I'm also abstract. So from your writing, from your answering, I can know what you are thinking. Every time I think, why I want to waste time in this non-change, like no improvement one. You got, I acknowledge you got, but the others don't have, you know. So it's like wasting my time. At least not now. Last semester, yes. Now, yeah, this semester, okay. This semester you are good. I know you are good. From the way you interact with me, you ask the right question, then I know you are performing already. And then the way you come to class, how you come to class, you come to class on time or not, or you come to class late. This is all how you see this class, how you care about this class. If I don't care about this class, I also come late every day. Correct or not? Yeah. Yeah, I know you are improving. Actually, your grade is okay already, normal. Normal. After scale, you can see how high you get. Yeah. Not until good, but normal already. Yeah. You can keep improving until you become the best. The best yourself. 100. What else you can go? In this class, I don't know, depend on your class like this. Not stable. Flip here, flip there. Okay, yeah. So I cannot tell you. The other class, let me tell you, I teach the Seng calculus too. Okay. Last year, the highest score is, last semester, the highest score is 92, right? This year, the highest score is 98. Almost the same difficulty. Jimbo went for it. Jimbo come and try. Yeah. Okay. So it's achievable one if you really put in your effort. No need to put what extra effort you just need to put what you can do. Okay, yeah. Then you can achieve what you want. Okay, now. But the thing I scared is you just run away. Okay, I don't want you to run away from responsibility. Please don't do it. Okay, please don't run away. Okay, pick up your responsibility. People are here to help. Okay, I'm here to help. Okay, so I'm here to help. Okay, now. Okay, so please return me your notes, and then we have break until 9:30, and then for 20 minutes we discuss about free group, and then 9:30 we'll resume. New topics. Yeah, and
You have mentioned want to find bijunctive got the point.
okay.
Yeah, I didn't put the proof.
Let me take a note. Okay. So what did I say? Okay. So you say I can check. Okay. Okay. Oh, this 2 marks give for what? For freedom. Okay, okay. Okay, I give you 4 marks. Okay. Okay, bijunctive. Okay. Yeah, give you 4 marks.
Then more.
More.
This one where you say is wrong.
Because doesn't exist.
Because here I try to show that this is inverse of the left inverse. The point of the first part. So we can use this to show that.
Wait. So what you have shown is
If there's a left inverse, right? Then if the left inverse is like,
then you need to show x. This is E also. Have you shown this? Two direction. This one have to have two direction, not just x time here. X time L also need to be identical.
wait. Proceed it, but inverse.
Sure. But what is this? This doesn't exist. Do you know it exists?
Because like L is an inverse, so there must be a inverse of L, right?
No. I didn't tell you whether L is invertible or not. I just tell you that a left inverse and right inverse of an element exists. That's all. I didn't tell you whether inverse of left exists, left inverse exists or not. Inverse of right inverse exists or not. Or inverse of x exists or not. No, I don't know. I only know left inverse and right inverse of x. If they exist, then they have to be equal. I don't know whether 3 of them are invertible. You get what I mean? Yeah, this is the point of this question. I don't know each element is invertible. I just know that these two guys, they must be. That's all.
And then this one, I know I did wrong, but I got the concept that we need to find the LCM.
No.
I just,
Okay. Okay.
I misremember. I like you mentioned on lecture that we need to look for prime. I applied the wrong thing.
Okay, I can give you 2 marks here.
Then yeah, that's all.
That's all.
Yeah.
So plastics. Okay. Okay. Thank you. Yeah.
I think that I mentioned that the ice cream is rejected, but I only get
So this is for subjective, right? This is for subjective. How about injective? Sure about injective. You just do subjective. Yeah. You just show subjective. Bijective is injective and subjective. Yeah. So you only did one thing. Yeah.
你是变这样子写，是因为我没有 prove 只有 E 在里面。
你没有，你 prove 了。
我找到 E 了，可是我没有讲只有它，是因为
对。不要错。
然后给你了。
Yeah, 给我。Hello. If you're done with your tests, please give feedback to me. 我没有分的话点不上，因为我们要 scale， 你不用怕。
我只是看着好看一点吧，就是我
我们会 scale，
不是就是
什么？就是我们会 scale， 你知道什么意思吗？
啊，我知道。
Okay. 有分你才可以跑，没有分跑不到。因为你这样子好看，我也要给其他人好看嘛。呀，说看。对呀，你要找那个 S 给我啊。那你就要找啊，为什么就是你找不到？你都说就是了，为什么你找不到？你应该要找给我啊，对吧？你都说就是了，对不对？这样你就找给我啊，对不对？
我们全部，让我找。
可以帮我算数一下吗？你这样。
如果你有时间的话，
有，在办公室有。
我没弄错吧？就是那个 identity group 这个，它就是 identity。
啊，你知道这题是错的嘛？这句话是 false， 你写是 true 啊，这句话是 false 的。我们刚才已经讨论了，这句话是 false。你看一下，没事。我就是说你要理解一下这句话是错的，你知道为什么它错吗？这句话是错的。看理解错不用紧，但是你要知道为什么这句话是错的，你知道为什么吗？这个已经定了一个 r。and 这个 lambda， 所以比如说 determinant 等于2是一个 subgroup 吗？对，这就是我在讨论的，刚才一直在讨论的这东西，明白吗？对不对？你能够看出为什么如果等于2的话，它就不是 subgroup 吗？看得出来？
对，我还以为它 lambda
对呀，你知道为什么这个是选定一个 lambda？ 因为我的 for all 在外面，我选定了一个 lambda。你知道为什么如果我选定一个 lambda， 它不是一个 subgroup？知道了。因为如果你 DAB 等于 determinant A 乘 determinant B， 所以2等2就是调性不在句子里面，对不对？其实你这次做的蛮好的，做的蛮好的。后面呢，你做的蛮多。没事，我觉得挺好，我觉得你做的挺好，挺好的，我觉得不错。还有吗？你们都OK，没事，你做的挺好的。Hey, everyone, you can take your cheat sheet back if you like. Yeah, 可以。我觉得他写的很美，
你们可以看美，可以看博嘛。
有复印章。
You can take your cheat sheet back if you want. 51.6啊，比这一班还高，这个课啊，
那个
好，
数学我都写不
每个人都要头长。
哦，我的
但是我看不出你怎么修这个东西，
手里
怎么修这个东西，因为这个对这个对不是啊，因为你要是把这个写成这个 form， 它才会在里面，对不对？
要把这个，要把哪个写？
就是把 A 要写成这个 form， 才可以在 H 里面。这句话怎么 imply 这句话？
我只是觉得很像。
对呀，
这句话告诉你什么时候什么东西在 H， 你一定要写成这个形状，它才会在。
有人吹比较早，
对吗？
认出来了。
Okay, so please give back your test paper. So if you still want to talk to me about the marks, later we can go to office and then do it. Okay, we can do it in the office. 30. Okay. So for those who haven't give me back your score, please do it later. Okay. Medium 啊，没有算。等一下啦，等一下等你。Okay, for those who still want to claim marks after class, go to my office. Okay, go to my office. We'll do it in the office. And for those who want to claim marks, please, we'll do it in the office. Okay, let's continue. The topics. Okay, so what's the good of doing quotient group? I'll briefly go through what's the application of the quotient group, and then we'll go into free group. Okay, so first, okay, we will call a group simple. Let me remove this. Okay. So we will call a group simple if it is non-trivial and has no proper non-trivial subgroup. Okay, so meaning you don't have subgroup, proper subgroup. Okay, but proper subgroup include trivial group, so we don't want just trivial group. For example, what? For example, Z. Is there a subgroup, non-trivial subgroup or not? Proper one inside Z. 3Z. 3Z is a proper non-trivial subgroup. Okay, so inside Z, Z is not simple. Okay. So things that are simple is like cyclic group of order P. If you do tutorial question, you will see this. Cyclic group of prime order. There's no proper subgroup. Okay, every element here will generate a cyclic group. Okay, there's no proper subgroup. And then the other thing is the alternating group of AN is simple. Okay, so there's no non-trivial subgroup. So this example here is actually related to a Galois theory, saying that not all polynomial equation of degree 5 is solvable. It's solvable, I think. It's not solvable. Sorry, it's not all. Okay, not all is not solvable. So you cannot solve the polynomial degree 5. Not all degree 5 polynomial is solvable using radical. Okay. Alright. So this is the first part where the group theory comes from, I think. Galois theory. So Galois is a young man who died about 20, age of 19 or 20, because the story is like he is having a duel with people. I think it's because of affair. So because of girlfriend, I think. So he died. And then he wrote this theory inside a jail, I guess. That jail. Yeah. Galois theory. If you decide to go AA2, you will read this, I think. Okay, so what's about this simple group? So there's a theorem say that any group has a unique composition. Okay, series up to isomorphism. So you can write your group. Okay, you find the subgroup and then keep finding the subgroup until you reach the trivial subgroup. Okay, you can do this. This is called a composition series. So what's special about this series here? This series here, each HI is normal. Okay, I find a normal subgroup. Okay, all along the way, and HI plus 1 over HI is simple. Okay, so if you take a quotient, you can take a group, right? So because it is a normal subgroup, you can take the quotient. Okay, and then every quotient is simple. Okay, this is called the Jordan-Holder filtration for group. Okay, Jordan fusion, Jordan-Holder filtration for group. Okay, so this is true up to isomorphism. True up to isomorphism. So meaning what? Every group I can decompose in this way, and this is unique up to isomorphism. Okay, so meaning what? I just need to care about the factor here. I just need to care about simple factor. And then I can use all this simple guy to build my G. Okay, to build my G. Okay, somehow build my G. So this is the application of quotient group. I can decompose my group into this simple group using this Jordan-Holder filtration. Okay, and then people try to classify all the simple groups. Okay, is it finite? Can we classify it finitely? So what have we classified last time? We have classified all the subgroup of cyclic group. We have classified all the finitely generated abelian group, which is a product of finite order Z, a finite order cyclic group or infinite group. Okay, remember? And then now we classify the finite simple group. So these are all the classification. So either you are a cyclic group or either you are alternating group, either you are some special group. Okay, use these Lie group stuff to to classify, and then some exceptional Lie group, G, F, E, D, B label, and then all these special group, which we call a sporadic simple group. And then out of these group, there's one special group we call the monster group. The monster group is the largest simple group in this world. Right? So this proof takes about how many years? 50 over years. Okay, about 1,000 pages of a journal. Okay, 100 articles to prove it. Okay. Actually, it's a kind of fascinating how they found this monster group here. Okay. I have a graduate talk on the monster group. You can have a have a watch if you like. Let me see. So I have a graduate talk on this. If you want to listen, let me see. Yeah. So I think for now, I think you have knowledge to listen about half of it. This monster group. Yeah. You can listen about this monster group. Okay. How they discover this monster group. Yeah, question? Yeah. Is the group with the highest, I mean, it's the group with the, okay, it's the, okay, wait. So here. I cannot tell you, oh, okay. I cannot describe the group to you. Okay, what I want to describe to you is this is the, so what's monster here? How is it monster? Because this is only considering finite simple group. Okay, so we classify all the finite simple group, and then because this is finite, right? So every group has a cardinality. So monster have the highest cardinality. Yeah, monster have the highest cardinality about 2 to the something. What's the magnitude? I forgot already. Yeah, 2 times large magnitude. I forgot what's the magnitude. Okay, and then how they discover this monster group is like through representation theory. We will learn it soon, which is a group action. Okay, yeah, and then I cannot describe this to you because they use generator and relation, which we will do soon, which is free group. We will do it. How do we describe a group using just generators and relation? I cannot write all the elements for you, right? 2 times so large a magnitude. I tell you all how they compose. So the multiplicative table is like 2 times 10 to the billion things, right? So how do we make it? So we have a simple way to do this, okay, which is called the free groups. Go into free groups now. I think after a few lectures behind, you can read my paper already. Eligible to read my paper. Got one published, one should be publishing already. Just published. We got, but maybe not a big one. It's me and my other friend. Actually, my friend come from Penang. You are Penang Lang, right? Don't throw face on Penang Lang. Okay. Just kidding. Okay. Let's go to free group. Okay. So let's talk about free group here. Okay. We want to do some motivation first. Why we talk about free group? Okay. Let's take our favorite group. Okay, our favorite group. So how about take X3? This is the simplest. Is it simplest? Yeah, simplest non-abelian group X3. So what is X3 here? Permutation on 3 indexes. Okay, so what are the elements? Identity 1, 2, 2, 3, 1, 3, 1, 2, 3, and 1, 3, 2. We know that we are done because S3 has 6 elements, 3 factorial. Okay, and these elements are different from each other. But there's another way to write this. Okay, there's another way to write this. Okay, I claim that I can use just 1, 2, and 1, 2, 3 to generate all the things. Okay, I can just use these two to generate all the things. What can I do? Because what can I do? I can, if I want to use 2 elements to generate, what do? I just compose them together. Okay, for example, if I take 1, 2, compose with 1, 2, 3, what do I get? What do I get? I don't know how to calculate. 2, 3, correct? So I got 2, 3. Okay, so 2, 3 is in this group generated by these 2 elements. So I can use 2, 3 again, okay, to generate things. So 2, 3 times 1, 2, 3 is what? 1, 3. Okay, good. There's a faster way to compute, right? Like 2, 3 equals to, so let me show you a bit faster way. So 2, 3 times 1, 2 times 2, 3, okay? But if I want to move 2, 3 forward, I will switch the index of 1, 2. Okay, so 2, 3, 2, 3 cancel, and you get 1, 3. Okay, I already get 1, 3, 2, 3, 1, 2, 1, 2, 3 inside my group. What else do I need? I need 1, 3, 2, right? So how to build 1, 3, 2? I just take 1, 3 times 1, 2. I'll get 1, 3, 2. So how many already? 1, 2, 3, 4, 5. So the extra one is identity. So you just take 1, 2 times 1, 2. Since it is closed, then identity is in there. Okay? But realize that what have we used actually? We don't just compose. Okay, they compose by some property. For example, 1, 2 times 1, 2. Why is it identity? Why is it identity? This is from the the definition of the map. Okay, but in the point of view of group theory, this is the things that you impose. Okay, I need to tell you that 1, 2 square to identity. Otherwise, 1, 2 can square to other things, right? But it is the property of this S3 that 1, 2 square to identity. What else? We also have 1, 2, 3 that square to identity. That take cube or square cube to identity. Okay, so this is the relation also hold by this element here. What other relation? Okay, if you take 1, 2, 3 composed with 1, 2, it is equal to, let me see. So let me swap it first. So if I take 1, 2, swap with 1, 2, 3 is equals to 1, 2, 3 squared and 1, 2. Okay, yeah, this is what we have. Okay, and then you can check that with these three identity here, you can generate this calculation. You forget already what does 1, 2, and 2, 3 do. Okay, what do I mean by this? So let's say I let x equals to 1, 2, y equals to 1, 2, 3. The S3 group can be written as x, y, such that x squared is identity. Okay, and then y cubed is identity, and then yx equals to x squared y. Okay, so I forget already. I forget 1, 2 commute the 2 variable. 1, 2, 3 commute the 3 variables. Okay, I just remember what's the relation they take. Actually, what does this relation do? Yx equals to x squared y. Meaning what? Y and x doesn't commute. If it commutes, it means what? Yx equals to xy. But yx equals to x squared y. So this is a non-commuting group. Okay, non-abelian group. Okay. And then I tell you what's the order of each generator. Okay, and then I tell you how they interact. And then I claim that this is enough to give you S3. They are isomorphic, in other words. Okay, they are isomorphic. Okay or not? Any question? Maybe you don't know why is it true, but this is the fact you need to see first. Okay, and then later we will have enough tool to prove why is this true. Okay, I just have enough time to motivate you. Okay, any question about this? There are things I didn't make clear here, but I just let you see the fact. Do you understand the fact or not? The point I point out this thing here. So I just have isomorphism. Okay, I have an isomorphism. Or sometimes when we say that it is isomorphic to this free group presentation, we just say that equal. They are equal. Okay, because sometimes it's easier to work with this setting. Easier to describe. I don't need to write all the elements for you. Can you imagine just now monster have like 2 to the billion. I write everything for you. Okay, I just give you the generator. I just give you what relation is satisfied. Okay, then they'll give you the group. Okay, I haven't made things precise. This is just a fact I want you to see first. Then in the next class, we will define everything properly. Okay, can everyone accept this fact here? If you don't accept, this is still a fact, so you cannot run away. Okay, so a fact is a fact. You cannot just run away. Okay, if no question, we'll see you next class. Please, you can get back your cheat sheet, and then if you haven't returned me your test paper, please return it to me. If you want to claim marks, please go to office with me now.